Hi there, Pre-Calc gang. 6-7 is our lesson today. And notice we start out with a big chart on the other trig functions and some of their characteristics on the graph. And so I'd just like to talk about these a bit. You might want to pause the video and make sure you get this chart down because it's fairly important as we look at the graphs of these other trig functions. So first of all, we have tangent, and the tangent graph looks like this, so it looks a lot different than sine and cosine. Another thing that's different is the period of tangent, and its reciprocal, by the way, is only pi units. So it repeats itself every pi units instead of 2 pi. Now the domain for all these, notice, is not all real numbers because there are some places where it's restricted. In other words, there are some places on the graph where the tangent is undefined. And so you might recognize that a little bit from your circle chart. So in other words, multiples of pi over 2 are undefined in the domain for tangent. And that relates to our circle chart when we have some places where the tangent is undefined. Notice the range is all reals. Minimum and maximum there is none, so it's not meaningful to talk about an amplitude with any of these other trig functions. So take a little bit of time and write down this chart, and we'll be doing some problems related to this here in a bit. Notice the graph for cosecant, that's 1 over sine, and secant, which is 1 over cosine. Notice how strange those graphs look. In a sense, they kind of are little parabolas that bounce off the regular sine and cosine functions. The graphs here, I think, are just between 0 and 2 pi for tangent and cotangent, and actually the same for cosecant and secant as well. So this chart will be a handy thing for you to refer back to as we work through some of these problems here. I'll get right to them right now, in fact. Looking at these, first of all, evaluate the tangent of 4 pi by looking at the graph. Well, I have actually graphed this out, as you can see, and this graph goes from 0 to 4 pi actually. And so just looking where this might be, here's 1 pi is here, 1 pi, 2 pi, 3 pi, 4 pi, so 4 pi is right there. So just by looking at the graph, we can see that the tangent of 4 pi is going to be 0. That's something you could put in your calculator, but it's also good to have familiarity about what these graphs look like. And tangent repeats itself every pi units, and basically every even number pi, the value is going to be 0. Now how about this next one, the secant of theta equaling -1. Well, here's the secant function as we saw earlier, and by -1 I'm looking at this line right here. So what values of theta or x, these would be angles of course, give you a secant of -1. Secant is 1 over cosine. Well, sure enough, it looks like one of those places would be right here. That's going to be at pi. So we have 1 pi, 2 pi, and also at 3 pi over there. So really we could say my answers here are that theta could be n times pi, where n is an odd integer. So as we said, 1 pi, 3 pi, 5 pi, that type of thing would be my answer there. And then the graph definitely does help us in that regard in solving a problem such as this. The last slide here, not too lengthy of a lesson here. Could you graph this? Now, secant of 2 theta plus pi and then -1. So the key thing is when we graph secant or cosecant, it's a reciprocal function. So I have to graph it as 1 over cosine. Secant is 1 over cosine. Then I can enter the rest of this in there. Remember, we're graphing x instead of theta. Everything else should be about the same. And the -1, of course, is move the graph down 1. This is from 0 to 2 pi, I think. And so you can see how what this graph looks like. Pretty straightforward, but you just have to set your window correctly and make sure you have all the little nuances of the graph done correctly as well. And last one here then is write an equation for the cosecant function with period 3 pi, phase shift pi over 3, and vertical shift -4. So if we think about this, cosecant would look something like this. Really no amplitude as far as that goes, but otherwise kind of the same type of stuff we've been doing before. So it says if the phase shift is pi over 3, I can just put x minus pi over 3 in there in the numerator like that. If the vertical shift is -4, I can tack that on the end just like this. Now the question is, what do I put in my equation if the period is 3 pi? Well, cosecant has a period of 2 pi as you saw in our chart earlier. So again, we still have that same little relation that a value equals the period divided by 2 pi. So in this case, if the period is 3 pi, I really have 3 pi divided by 2 pi like that. Looks like the pi's would cancel out, so my a value ends up to be 3 over 2. And remember, it's that a value that actually goes into the equation. So there it is. That's the equation that we're looking for. If we graph this out, sure enough, we would see that it would have these characteristics. Now you could pretty this up a little bit. You could, instead of dividing by 3/2, you could multiply by 2/3, and it would look a little bit nicer, but I think it's better just to leave your full equation like this, because then we can pick out and easily name all these features of the graph. All right, we'll work on this in class tomorrow, gang. Thanks for watching, everybody, and we'll see you then.